the first hours of epic fury, the United States sent B-2S, B-1S, B-52S, F-15S, A-10S, and AH-64 Apaches into the fight at once. More than 1,000 targets across Iran were hit in the first 24 hours, including missile sites, command nodes, production facilities, and threats around Hormuz. From the outset, this was a layered air offensive aimed at disrupting how Iran launches, coordinates, rebuilds, and projects force across the region. 4 B-2 stealth bombers flew 30+ hour strike cycles, delivered 2,000-pound GBU, 3 1J-dams with Blue 109 penetrator warheads against hardened ballistic missile facilities and cracked open the first layer of Iran's launch network. 3 B-1 bombers followed with strike loads of up to 75,000 pounds, hitting missile sites and command nodes left standing after the initial wave. Next up were the B-52S. With 70,000 pounds of firepower each, they took that initial hit and just kept it coming, over and over again. The order of the strikes was key. It was about disabling the machine, instead of just making a statement. Washington wasn't looking for a flashy headline or a pretty map. It was trying to slow launches, narrow Iran's missile options, and force the war into a different rhythm before Tehran could recover. By March 4th, Iranian missile launches had plummeted 86% from where they started on day one. Access, timing, coordination, survivability, all of it was already under strain, and that was only the opening layer. In the beginning, the B-2 was the go-to for the first phase for one simple reason: you've got to get through the door before you can bring the heat. Before heavier waves could arrive in force, the United States needed an aircraft that could cross long distances, enter defended airspace, and reach hardened targets quickly enough to unsettle Iran's response cycle. The B-2 can fly roughly 6,000 nautical miles without refueling and carry up to 40,000 pounds of munitions. More important, it could neutralize high-value, deeply buried targets across Iran. Those early targets were not random. Hardened ballistic missile facilities and underground launch infrastructure sat near the center of Iran's deterrent model. Missile cities were supposed to provide protected depth, survivability, and continuity, yet underground systems can lose military value without disappearing. Damage the entrances, cripple the exits, break the access points. Suddenly, the same tunnel network no longer works like a launch machine. It becomes storage with limited utility, trapped capacity waiting on repairs, clearance, and time. Visible destruction was only part of the effect. Some of the most serious damage was functional. Iran's missile network was not erased in one night, but once it lost enough access, launch continuity, and timing, the remaining architecture could no longer operate at the pace it had been built for. That is how a dangerous system starts narrowing in real military terms, even if parts of it are still physically there. By the end of the first phase, the campaign had already reduced the usable value of one of the most important pillars in Iran's war model. After the B-2S disrupted the launch layer, the campaign changed shape. Stealth still offered a combat advantage, but the campaign was shifting toward heavier strikes and continuous pressure. The next step was sustained pressure on the parts of Iran's military system that were still operating. That is where the B-1 came in. 3 B-1 bombers joined the fight with payload capacity up to 75,000 pounds, giving the United States a platform suited for heavy follow-up strikes across a wider target set. More than 1,000 targets were reportedly hit across Iran in the first 24 hours. Within 48 hours, the broader tally had already climbed past 1,250. February 28. Launch networks, command structures, and surviving defenses were being hit close together, leaving less room to absorb one shock before the next arrived. The B-1 picked up where the B-2 left off. Missile sites remained central. Command and control centers were becoming just as important. A missile force is more than launchers, fuel, and storage. It also depends on orders, coordination, targeting flow, and transmission speed. Once command nodes start falling alongside launch infrastructure, the damage spreads beyond hardware. The system starts losing rhythm, decision-making slows, instructions move less smoothly, and coordinated firing starts to break down. A force can still hold missiles and still look threatening in inventory terms, yet behave like a smaller force in battle because its internal tempo has been cut down. If the B-1 brought heavy follow-up firepower, the B-52 brought sustained strike endurance. Its roughly 70,000-pound strike load and long-range mission profile allowed Washington to keep pressure on target sets that required repeated punishment rather than one dramatic opening hit. By March 5, the campaign had struck more than 2,000 targets, including over 20 Iranian warships taken out of commission. By March 11, that figure had climbed past 5,500. With at least 3 B-52s described at the base, and with a larger B-52 force listed at 58 active aircraft plus another 18 inches reserve, the United States had a way to shorten turnaround, reduce the strain of extreme round trips, and keep heavy bombers in constant rotation. The challenge had shifted. Iran was now facing repeated strikes on missile sites, command nodes, and the military production base. At this stage, the target set expanded. The campaign had moved beyond what Iran had already built or already fired. It was now moving toward what Iran could still replace. That shift brought the F-15 into focus. By then, degraded air defenses and damaged launch sites had already changed the air picture. A broader issue was coming into view: whether Iran could keep regenerating combat power through drone production, replenished strike capacity, and continued coercion around the Strait of Hormuz. The industrial layer sat behind the visible fight. Strikes on launchers can reduce immediate output. Strikes on production can reshape what remains possible a week later, a month later, or longer. That logic showed up clearly in Iran's drone war. Shahed drones were dangerous less because each one was advanced than because they were cheap, numerous, and disposable. Their costs stood at roughly $20,000 to $50,000 per drone, while a Patriot interceptor can cost around $4 million per shot. That is a punishing exchange ratio in a prolonged campaign. In the first week alone, Iran launched over 1,000 drones. Before the war, it also had the capacity to produce as many as 10,000 Shaheds per month. That turned drone production into a replenishment issue rather than a mere battlefield irritation. Washington adapted. Instead of trying to kill every drone in the air, it began striking the facilities that made the drone arsenal renewable. One example was a March 24 strike on a drone engine manufacturing plant. Targets like that sat behind the immediate threat: damage engines, airframe components, and key production sites, and stockpiles begin moving in one direction, downward. Numbers may stay high for a while. Sustainability starts weakening first. All of that fed directly into Hormuz. By then, the Strait had become more than a waterway on the edge of the war. It was Iran's last major lever for imposing costs beyond the battlefield. At least 16 commercial vessels had already been hit. Oil had climbed to around $120 per barrel, and more than 1,000 ships had been blocked from entering the Strait by March 16. That also explains the F-15's place in this phase beyond air-to-air work or inland strikes. With speed around 1,875 miles per hour, range around 3,450 miles, and a weapons mix flexible enough for both strike and patrol roles, it could operate at the center of a phase, linking inland production targets with maritime pressure points. By then, the campaign was reaching beyond launch sites alone. It was beginning to cut into Iran's ability to regenerate coercive force at all. Iran still had one response layer that was smaller, cheaper, and harder to shut down from high altitude alone. Fast boats, naval mines, and low-cost drones gave Tehran a way to keep the Strait dangerous even after repeated strikes had damaged the heavier parts of its military machine. Apache helicopters and A-10s entered the sequence at that point. These were not prestige platforms. They were practical tools for the messier layer of the fight. The Apache fit that kind of mission first. It could fly low, track small moving targets, and hit them quickly with weapons sized for the threat in front of it. The helicopter carried Hellfires, a 30mm chain gun, and 1,200 rounds, with a firing rate around 620 rounds per minute. That loadout suited a battlespace shaped by speedboats, drones, and fast maritime harassment rather than formal fleet combat. Iran's small boats were useful, even without sinking a major warship. Civilian traffic only had to see the crossing as too dangerous to justify. Put Apaches over that water, and the harassment layer starts looking less like a shield and more like a target set. The A-10 approached a related problem from a different angle. It was slower, tougher, and built to stay in the area. Its loitering ability fit a fight where threats appeared in bursts and disappeared quickly. An aircraft able to operate under a 1,000-foot ceiling, hold visibility out to 1.5 miles, and remain overhead waiting for targets, was well suited to a cluttered maritime battle space. With speed around 420 miles per hour and lower-cost weapons such as APKWS, the A-10 gave the United States a way to stay persistent without spending high-end air power on every small contact. That gave it value against drones and fast boats, while also helping cover mine-clearing vessels and keep steady force on the coastal layers supporting Iran's blockade tactics. Taken together, the Apache and the A-10 showed how far the air picture had already shifted. Heavy bombers opened the war. Fighters pushed it toward production targets and choke point warfare. Washington was now bringing in aircraft built for low-altitude persistence and close hunting over the very layer Iran had hoped would stay dangerous the longest. Once that layer came under sustained hunting, Tehran began losing more than hardware. It began losing the final low-cost method it had for keeping Hormuz unstable on manageable terms. B-2S opened access and struck the launch layer first. B-1S increased strike volume against missile sites and command nodes that still held operational value. B-52S turned that opening success into sustained attrition. The F-15 phase pushed further, shifting away from what Iran had already fired and toward what it could still rebuild. Apache helicopters and antennas entered the lower and more chaotic layer of the fight, where drones, mines, and fast boats had kept Hormuz under threat. Taken as a whole, the campaign was aimed at function as much as destruction. Iran could still retain weapons, sites, and platforms. Inventory, however, is different from usable strength. As launch continuity narrowed, command flow fractured, production capacity weakened, and maritime harassment came under attack from above, the same military system began operating very differently from the way it had at the start of the war. It could survive in pieces and still perform worse as a whole. That was the larger shift. The map may not have changed dramatically. The tempo had. In a campaign like this, tempo shapes choice, recovery, sequencing, confidence, and risk. Iran could still possess tools of war. What it was steadily losing was the ability to use them on its own terms.